So now that you've learned all about permutations, we're going to take a look at combinations. So that's section 11.2, and this is where it starts to get a little bit tricky because you have to ask yourself always, does order matter? So for instance, if we had three people show up, so you're having a party and you're waiting for three friends, do you really care who comes first, second, or third? Probably not. You just hope that they all show up. And that's kind of like combinations. We don't really care who comes first, second, third, fourth, whatever. We just care that they're there. And the formulas also look different as well. So for the formula for permutations is n pick r. So we have n factorial over n minus r factorial. Okay, you've seen that. The combination formula looks very similar, but you're going to notice this extra r factorial. And what that is to get rid of any duplicates. So any place where those same three might be in there, but they're just in a different order. So if we look at the pizza, it can have a possible 7 different toppings at the store, and we want to have 3 toppings. Do we really care which toppings the order is in? Like when we're ordering it? No. So then how many different pizzas can be made? Well, we've got 7 choices, so that's going to be 7C. And then 7, choose 3. Now when I'm doing this, I can also do it my other way using the fundamental counting principle. And I can say, hey, I've got 7 choices for the first one. Oh, and then I've got 6 choices. And then I've got 5 choices. The problem with this, though, is there's going to be some duplicates. So there's 1, 2, 3 different ways this could be rearranged in here with having the same ones. So we're going to divide this all over 3 factorial. And that's going to get rid of those duplicates because let's just say we had pineapple and pepperoni and I don't know, shrimp. Oh, that sounds like a delicious pizza. If I just look at how many different ways I could rearrange these 3 things, well, I've got 3 options here. So option 1 is 3, then we got 2, then 1. Oh, well, that's 3 factorial. And so that's where this is coming from. There's 3 factorial ways for these 3 items to be chosen if the order counted. But we don't want to count order, so we got to get rid of those different options. And so that's where we get that from. And if we look at our combination equation then, so you end up with 7 factorial all over, we're choosing 3, so it's going to be 3 factorial, and then n minus r, so 7 minus 3 factorial. And when I go to do this, so we go 7 factorial, 3 factorial. So you know what? I'm going to simplify this numerator a little bit first. So 7 minus 3 is 4 factorial. And what I want to do is do some cancellation. So if I've got 7 factorial in the numerator, well, and 4 in the denominator, I can cancel that 4 factorial. If I rewrite it as 7 times 6 times 5 times 4 factorial, so those 4 factorials will cancel out. And so you're left with 7 times 6 times 5 all over 3 factorial. Hey, that's the same thing we got here. So I'll just throw that in a calculator and I will get 35. So we got 35 different pizzas we could make out of 7 toppings. Example 1. So there are 12 females and 18 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. So how many selections are possible? Again, first question, does order matter? So does it matter which one is drawn like out of a hat first or something? Or how they're... No. It just matters that we have so many students, so 5 students. Doesn't even matter if they're male or female right now. That's it. So that's going to be a combination question then. So there's 30 possibilities, so 12 plus 18. So I've got 30, and then 30 choose 5. Now I could throw that into my calculator right now. Just like we have with the permutation button, there is a combination one. And I'll show that in a second, but let's just do that with factorials first with the formula. So you know, with 30 factorial all over 5 factorial, and then 30 minus 5 factorial, and we end up with, we could simplify this more if we wanted, but I actually want to look at something different right now. So we get 5 factorial and 25 factorial. There's a good little double check here that you've done it correctly, the formula. Our denominator should equal our numerator. So yeah, 30 is equal to 5 plus 25. Perfect. Okay, so let's put this in the calculator then. So we had 30, and then math. It's under probability, and then number 3. So that's our combination. And we're picking 5 people. Okay, hit enter, and we get 142,506. So that's how many different groupings we could have. So there's a lot of different possibilities there. So B, how many selections are possible if the group consists of 2 females and 3 males? Okay, this is getting a little bit more complicated now. So we've got 2 different situations here. For the 2 females, we only have 12 options. So it's going to be 12, choose 2. And then for the males, well, there's 18 possibilities. So it's going to be 18, choose. We want 3 of them. So because we could have each different combination of females with each different combination of males, we're actually going to want to multiply these together. Now, well, I know in the calculator you could put this in there, but let's do this using factorials. So it's going to be 12 factorial over 2 factorial, that's our r, and then 12 minus 2. And you know what, just to save some time maybe this time, we'll just say, hey, we can do that in our heads. 12 minus 2 is 10. Just checking, does the denominator match the numerator? Yep, perfect. And then our second combination is 18 factorial, and that's going to be 3 factorial over, 18 minus 3 is 15. And there you go. So let's see if there's anything we can simplify here. Well, these numerator and denominator, we could both make the factorials of 10. So we could have 12 times 11 times 10 factorial. And the denominator would stay as 2 times 10 factorial. And then for this one, we can make the factorials both 15. So we have 18 times 17 times 16 times 15 factorial. That's going to be all over 6, because 3 factorial is 6, and then 15 factorial. So then we can cancel out our 15 factorials and our 10 factorials. And there's probably some other things we can cancel out here as well. So we've got a 2 and a 12, so this becomes 6. And then we've got an 18 and a 6, so that becomes 3. So now it's just really 6 times 3 times 17 times 16, which gets us a grand total of 53,856. So quite a bit less than before. Okay, the final part of the question. One of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female, and 3 males are possible? Alright, so now we've got 3 parts of this. Well, Brooklyn actually makes this easier because for the first position, we only have 1 choice. That's it. Now for the other female position, we have, well, there's 1 less female, so it's actually 11, choose only 1 of them. And then for the 3 male ones, you're going to have the same thing we had before, which is 18, choose 3. This time I am going to just use a calculator to put it all in there and see what we get. So just to show you can do it both ways. Again, it depends what the question's asking for. If it says it needs you to do it using factorials, or there's some kind of variable in there, you won't be able to use a calculator, and that's how they're going to get you. So 11 math, and then probability, 3, 1 times, I don't need to times this by 1, it's not going to do anything, but this is not in the right spot, times 18, and then back to our probability, 3, and choose 3. So considerably less, only 8,976. 8,976. There we go.